Hello, today we're going to talk about the structure of metals and alloys. So if you have a metallic substance, or it's just metals, you're going to have the valence electrons of those metals be delocalized. And that means those delocalized electrons are free to move about between different metal ions. They're not specifically assigned to one atom. Sometimes we call that a sea of valence electrons because they're free-flowing. This allows the metals to have a lot of unique properties, like they can conduct electricity as a solid. They're also very malleable because they don't have those rigid locations for bonds. You can bend it and shape it into different things. Metallic bonding is also dependent on Coulomb's law, so the size and distance affects the strength of the metallic bond. But yeah, most of this is a review from the last section. Now we can also make mixtures of metals. So when you have just a pure metal, you're going to see just one type of atom with the mobile valence electrons. Now these pictures don't show electrons, but you need to imagine that they're there just kind of floating around, okay? And for all of them, you're going to have those mobile valence electrons, okay? Now, the two types of alloys that are possible are substitutional and interstitial. Substitutional is when you have a very similar size between the two types of metals in your alloy, similar size, similar radius. So that way the new type or the additional type of metal can just take the place of the original one. But it's going to maintain a very similar structure. An interstitial alloy, on the other hand, you're going to see a much larger difference in the radius of the two substances present. So the smaller one will be able to fit in the gaps between the larger one. You still have those mobile valence electrons, but you'll also have smaller atoms fitting in between. This makes interstitial alloys much more dense and rigid because it's filling in the gaps. So for this example, it asks you to draw a model of the alloy steel, which is a mixture of iron and carbon atoms. So he's going to use your periodic table and look at the difference in size. So carbon is much, much smaller than iron. So you can draw your iron atoms. And because carbon is so much smaller, it will form an interstitial alloy. And the carbon atoms will fit in between the spaces of the iron.